This video is going to work with per capita as a rate, and we're going to work primarily with the information associated with this table, in which we talk about 7 countries, the number of homicide deaths in those countries, and then their populations and how they relate. So the first thing we're going to do is kind of work on the homicide deaths per capita. Now, do take note that the population is in millions. So we're going to start, and we're going to do Canada together. And we're going to go through all 3 pieces of the table, and then I'm going to ask you to kind of work the rest of the table on your own before you come back to check your answers. So remember, if we're trying to find the homicide deaths per capita, so remember that capita means people. So we're going to put the number of homicide deaths on top, and for Canada, that would be 543. And then the population, or the people, is 35.5 million. Million is times 10 to the 6th. Now, depending on your calculator, some calculators, when you type this in, it'll give you scientific notation. Some calculators will give you standard form. It is your job to be able to go back and forth between. So when I type this in, and for some of you, you might need to put your denominator in parentheses, depending on how it's typed in. My calculator spits at me 1.53 times 10 to the negative 5th. And that's, I rounded that to 1.53. Now, we know that this is scientific notation. Okay, so that's one of the columns, but it also asks for the rate in terms of standard form. Now, we know if we have a negative exponent here, this negative exponent, it means our number is going to be less than 1. So I move that decimal 5 places to the left. So 1, 2, 3, 4 zeros, and then the 1, 5, 3, because this 1 will count as one of those 5 decimal points. So this is standard form. Okay, so if we go to our table, that's this is the 0.0000153. And this is the 1.53 times 10 to the negative 5th. Now, I don't know about you, but it's hard to really understand that 0.0000153 deaths happen per people in terms of homicide. What? It's hard to comprehend that. So when we look at the last column, this last column here, the death per 100,000, what that means is, instead of looking at, when we talk about deaths per capita, this is per 1 person, this we'll talk about per 100,000. It gives us a better way to actually think about things. And the way to do that is we take this, the rate per 1, and we multiply by 100,000. So instead of being out of 1, because this is out of 1, it'll now be out of 100,000. So when I take 0.0000153 times 100,000, I get 1.53, and that's out of 100,000. So that tells us, this 1.53, if we would take 100,000 people, put them in a room, approximately 1.5 of them will die by homicide. That's what that means. Now, 100,000 people is roughly how many people can fit in Michigan Stadium. So if you think about Michigan football, 100,000 people. So think about that stadium. Of all the people in there, this is in Canadians, 1.5 of them will die by firearm. Or excuse me, by homicide, excuse me. Could be any method. So that's kind of how we do this. Now I want you to hit pause and try this, going through this method, where you take the homicide deaths divided by the population, and you do it in scientific notation, standard form, and out of 100,000. Try it, come back, and then see if your answers match up. All right, hopefully you can read this pretty well. I'm going to give myself a black line here, kind of separate those two. The exponents, you can see some of them are at -4, some at -5, 1, -6, Japan. And again, it's hard to compare decimals of that smallness or the scientific notation because, you know, those exponents kind of just throw in a different thing. But when you look at the death rate per 100,000, which is that last column, it gives you concrete numbers. It is easy for all of us to say that 30 is bigger than 20, right? We don't even have to think about that. We know that 1.5 is less than 4.6. Those are easy, quick comparisons. So by using that last column, it gives us an easier way to compare, still out of the same big number. All right, so let's look at this. Use the death rate per capita in the U.S. for a meaningful sentence. Well, the death rate per capita for the U.S. is 0.0000465. So that means there are that many homicide deaths for every one person. And as we said earlier, that doesn't make any sense. And it's hard to comprehend such a small number in terms of deaths because you either die or you don't. That's one. So that just really makes it difficult. But then we did the per 100,000. So now let's look at Colombia. The 100,000 rate for Colombia. Well, Colombia 100,000 homicide rate is 30.69. So that means there are 30.69 homicide deaths in Colombia per 100,000 people. So again, think about Michigan Stadium. If you would fill Michigan Stadium with 100,000 Colombians, about 30 of them would die by homicide. Okay, but it's got to be Colombians because it's different per country. Now, is the rate per 100,000 people ideal for every country? And you might say, well, yeah, they're easy numbers. Well, I want to draw your attention to Japan. Because for Japan, we're talking about 0.35 homicides. So it's hard to think about 0.35. That's a third of a person dying. And that doesn't work. You know, we have Colombians, we have 30.69. You can round that down to either 30 or to 31. And you can, it's not fun, but you can, think about 30 people dying. In Japan, 0.3, that's difficult. So what might be a better scale for Japan? Well, if we need, again, this just sounds bad, but we need more people to die. So if you need that number to be bigger, remember, back when we did in Japan, we had the per capita rate of this. And we multiplied by 100,000 to get it to be out of 100,000. Well, if I would multiply this by 1 million, this would give me 3.5. So I could say, out of 1 million Japanese people, 3.5 would expect to die by homicide. So now you got 1 million people, and I don't really know how you can, think about 1 million people. Nothing really comes to mind. But if you have 1 million people, approximately 3 or 4, if they were Japanese, would die by homicide. So the 100,000 really wasn't efficient for Japan, but maybe out of 1 million would be sufficient. Now this last piece, I want you to go back to the table and hit pause, go back to the table, and rank the countries from low to high in terms of population, who has the lowest population, who has the highest, and all in between. The number of deaths. So this one here is the number of deaths, and then this is the death rate. And you can use either the per capita or the per 100,000 because they're consistent. Who has the smallest and who has the largest. Then come back and look at them, and I'll explain kind of maybe some nuances that we see. All right, so just some interesting things. You'll notice that in population and number of deaths, Australia ranks the lowest. But when you go to the death rate, they're now the second lowest. In Japan, who has the lowest death rate, right, also has one of the larger populations. So it's just interesting to look at, Canada. They spend all three near the bottom, second or third from the bottom. The U.S. has the highest population, but they're middle of the road in number of deaths and in the death rate. Colombia, middle of the road, highest death rate. So it's just interesting to see how things kind of compare, but you always got to think about the number of people does make a difference. The more people you have, the more deaths you would think you would have, whereas Japan showed us that just because you have a lot of people doesn't mean you have to have a lot of homicides. So things are different depending on what you all have.